Hello, welcome to this presentation of International Plumbing Code Chapter 9. My name is Thomas, and in this presentation we are going to continue our discussion of the different methods that can be used for venting drainage pipe, and there are a variety. Remember, these different methods are like tools in your tool bag. The more that you know about them, how to use them, and when to use them, the better off you will be as a plumber. Now let me explain, as we get into these different methods for venting drains, that the most basic of all methods would be individual vent, to provide a vent for every single trap. Now that is very labor intensive. It takes a lot of pipe. As we compare it to some of these other methods, we looked last time at common vent, where you can get 2 traps on one vent, and wet venting, where you can get up to 6. That's 2 bathroom groups on a single vent. But then the question becomes, is this really the same? I mean, is it as effective? Are we going to have problems with vents if we start removing the number of individual vents? And let me submit to you that, in my opinion, the International Code Council is not going to write and prescribe a way of doing vents for an international audience without having done a little bit, if not a lot, of engineering and research on how this works. Now, I had an instructor when I was an apprentice who had used the Uniform Plumbing Code and believed the only way to vent was to individually vent everything. And it works. It does. But he told us, as Utah was transitioning over from Uniform Plumbing Code to International Plumbing Code, that all of our venting systems would fail. These wet vents and these different options are not going to work because they don't provide enough air, and that we would go back to the Uniform Plumbing Code and back to the way things were. It's been over 20 years. That has not happened. These venting methods are proven. They work. They're tested. But you have to know how to install them, and you have to install them correctly. And when you do so, then you can provide enough airflow with the vents given to more or to multiple fixtures without having failure of the drains because there's insufficient vents. There's a lot of people with opinions on this. Let me just emphasize that these other methods that we're going to look at, they work. They're tested and they work. Have a look now at section 913, waste stack vent. You can see in the diagram here what this is about. We have a stack with fixtures connecting into that stack. This is able to accomplish quite a bit. You can see how many fixtures. We now have 12 fixtures as a maximum for this particular 3-inch stack that can be connected in, all these kitchen sinks. Now obviously this only works if you have the identical layout or fixtures stacked right on top of each other from one floor to the next. But when that is the case, if you can run a pipe completely vertical up through all of that, you can catch quite a few fixtures. Here are the requirements for a waste stack vent. 913.2 says, first of all, the stack has to be vertical. And second, that means no horizontal or vertical offsets. Now, when we talk about a vertical pipe, we've talked in the past about how that can include all the way over to a 45-degree offset. But in this particular case, that is 0 offsets allowed. No 45s, no 22s, nothing, just complete vertical pipe. Another requirement is that the fixture drains connect separately to that stack. Every trap has to be connected. And this is not for use for toilets or urinals. This is mainly just for other fixtures. Section 913.3 says that you have to have a stack vent coming off of the top of a waste stack vent system. So right off the top you have a vent, but you can offset or header those together. You can connect your vents once it passes that 6 inches above the flood level rim from those upper fixtures. You can start to move the vents around, tie them together, but the drain itself has to be completely vertical, no offsets. 913.4 gives us the sizing for these waste stack vents. First of all, stating that the waste stack vent shall be the same size throughout its whole length. Everything from bottom to top, same size pipe. And here we have a table that helps us to know how many drainage fixture units can go into that. So you see on the left the stack size, that's the pipe size. And then we have The middle column, the total discharge into one branch interval. There's not a lot of limits once you get into larger pipes, but the smaller pipes are rather limited. And then we have the total discharge for the stack. These are the drainage fixture units that can go into that pipe size. Have a look at this line for a 3-inch pipe. If we have a 3-inch stack, it can have 24 total drainage fixture units. Now compare that again with back in chapter 7. How many drainage fixture units can a stack handle? Well, for more than one branch interval, you can get up to 48 drainage fixture units. So already we're seeing here a limitation on the number of drainage fixture units allowed into that stack. And what does that do for us? That enables for open air space. That creates a vent. Now it's a little more difficult to find opportunities to use the waste stack vent in a residential setting, mostly because fixtures don't generally line up right on top of each other, and often frame walls don't land right on top of each other. But if you can find an opportunity, it is possible for you to do something like this. You've got a basement and a first floor, maybe there's a laundry tray in the basement, kitchen sink on the upper floor. If you can go completely vertical with a 2-inch pipe all the way through the roof, you can use this waste stack vent form of venting, where you have the upper fixtures and the lower fixtures all going into the same pipe and being vented together. Here we have a diagram of something similar in a residential setting. Now we've got a second floor on top of that, but once again, if you can get a straight shot up with the same size pipe, this time we have 3-inch because we're adding more drainage fixture units. You can see from the top down we have a lav, bathtub, kitchen sink, laundry tray, clothes washer, all these things coming together on this single stack, 3-inch just going up through the roof. Now before we go on from the waste stack vent, let me just emphasize the fact that if you were to take this exact same diagram and then use a vent stack next to that, right? Because you're more than 5 branch intervals here, and you've got all those fixtures. Imagine how much extra pipe and labor it would require to run an additional vent stack all the way up and have all of those vents coming across and tying over to it. That's a lot. I mean, more than double the amount of work, pipe fittings, and everything. So this accomplishes a lot, and if it's done correctly, it works fine. Let's go on to section 914. This is called circuit venting. A circuit vent is a horizontal pipe with a series of fixtures coming into that, and it's being vented by one vent. Let's have a look at how this works. Requirements for a circuit vent include: it has a maximum of 8 fixtures connecting to that horizontal branch. So there's a limit to how many we can get on there with one circuit vent. Another requirement is that every fixture has to have an individual connection to that horizontal branch. Now, similar to wet venting, what we're looking at here is using that drainage pipe both as a drain and as a vent. The number 3 consideration is that the branch vent is considered a vent from the most upstream fixture. We're going to provide a dry vent for this system, and it has to be a dry vent. That has to come between the 2 most upstream fixtures in this horizontal branch. And once again, that vent is not allowed to have any soil or waste coming into it. It's completely a dry vent. Take a look at this illustration. We have 2 bathroom groups. You might look at this as, hey, this could just be wet vented, but the problem is we have added a bidet in the middle of this. So in addition to the lavs, toilets, and tub shower, we have a bidet, and that exceeds the number of fixtures that can go on to a wet vent. If you remember, we're limited to 2 bathroom groups, and now we've exceeded that. So what do? Well, now we look at this a little bit differently. We've got a common vent at the top with 2 lavs, but then starting at the toilet, we have a horizontal branch, and we consider this a circuit. And we're going to use a circuit vent between the 2 upstream fixtures. That would be the toilets. Run a dry vent off the top of that, and now all of those fixtures from the toilet down to the bathtub are being considered vented by that circuit vent, meaning that that horizontal drainage pipe is serving both as a drain and a vent, and it's getting air from the circuit vent. Now, interesting note here that's different from wet venting, and that is you can have additional fixtures coming through or into a circuit vent like this. So you see the lavs coming in there. You could add other fixtures, tying them in. And this is where understanding how that circuit vent works, knowing that you have a horizontal branch, horizontal drains coming into it, and that you're going to vent between the two upstream fixtures, that's going to be key. What I'm saying is you have to be able to see this, define this, and possibly even explain it on an inspection, how you have planned this out, how this works. In this diagram, we see that once you have completed a circuit that's 8 fixtures connecting to that horizontal branch, you can start over a new circuit, establishing a second circuit downstream, and we just add another circuit vent. You can tie those together. Here's another example of multiple circuit vents. These are obviously in different restroom areas, but 2 circuits being laid out and vented, tied together, and run to the vent stack. Another option is to run fixtures back to back. You can see here we have 8 water closets. The circuit vent is between the 2 upstream fixture connections. Now, even though that's between those 2 back-to-back toilets on both sides, we're still between those upstream branches, and so we're able to run that as a circuit. But in this case, we have those 8 fixtures, and they're sharing connection points where they're back-to-back. Now 914.3 talks about the slope and size of the horizontal branch for a circuit vent, and it gives us quite a steep slope. In our other drainage slope rules in Chapter 7, we're kind of limited to 1/8 inch, 1/4 inch, 1/2 inch per foot. In this, it gives us all the way to 8.3%. That gives us basically 1 inch per foot is the maximum uniform pitch. They want to see even slope, but you can actually have a fairly steep slope when it comes to a circuit vent. And when it comes to the size of the drainage pipe, we just have to be conscious of the number of drainage fixture units going into that. So you can see in the middle of this diagram, after having passed so many of the fixtures, they're going to increase that as it continues to pick up fixtures downstream. And that's all going to be based on our Chapter 7 drainage sizing. Now there is another important requirement to be aware of when you're dealing with a circuit vent, where that connects into a stack that catches fixtures from somewhere above. An additional relief vent has to be connected downstream from the circuit, but just before or in between where it connects to the stack. This provides additional airflow on the downstream side of that circuit, knowing that it may be affected by what's happening inside that stack. Now we talked about how the circuit vent has to be a dry vent, but the relief vent for a circuit vent can be a wet vent. It can have drainage fixture units up to 4 coming into that. So we see in this diagram on the far left, we've got the stack that's catching fixtures from above. This circuit is going to be coming into that, and there's a relief vent, and they're using that as a drinking fountain drain as well, but that provides relief to the fixtures. You can see also within this diagram, we have a series of water closets, floor drains, lavatories. We've got more than just that circuit vent. The circuit vent comes up between those floor drains, and we're considering that circuit from the upstream floor drain down to the end of those toilets. All of those other lavs are being common vented. That's great. Having more vents or more options is not a bad thing. But here we can see the use of multiple types of vents and a relief vent at the end where it connects into a stack. Section 915 gives us information about the combination waste and vent system. Now this one's a little mind-blowing if you are of the mindset that the only way you can vent is to go up and to go out. That's not happening here. In fact, if you look at the diagram, it looks like an S-trap. But I want you to pay close attention to the fact that we're still going to provide air. Let's see how this is used. The requirements for a combination waste and vent system include limitations, meaning you can't use this for any and every fixture. It's only for floor drains, sinks, lavatories, and drinking fountains. No clinical sinks. That's like a big square mouth toilet for bedpan washing. That doesn't count. Now it also is limited to a vertical rise of 8 feet. Have a look at this diagram. We have a number of fixtures, sinks, lavs, floor drains. Most of these are being vented using the combination waste and vent. You see on the left side a sink. The pipe rises up, comes over, traps. Same with the lav. And the floor drains are just extending out. Now we do see a vent coming off of the sink at the end, but remember we have a requirement on vents that anytime we have a building drain, at least one vent has to go all the way out the roof. That's what they're accomplishing here, because you can see there's the building drain, and we've got to have something that goes up. Now in section 915.1, it used to limit the combination waste and vent to sinks not including a garbage disposal, but they've gone and taken those words out in the 2021 version of the code. So even a garbage disposal could be hooked to a system that has a combination waste and vent. Let's have a closer look at exactly how this works. The point and purpose of this is to provide airflow by increasing the pipe size. You see here in this diagram that we have an 1.5 inch trap for the sink. As soon as it comes to the 90 where it will turn into that vertical stack, we've increased the pipe size to 2 inch. What does that do for us? That provides a lot of open space inside, additional air, which allows that drain to flow properly, even though there's not a vent that rises up and out the roof. Have a look at this plan view. We have a mechanical room and a restroom area. Combination waste and vent can be very useful for floor drains in a mechanical space like this, because you're able to catch all of those floor drains without having vents coming up. Can you imagine in this open mechanical space having vents coming off of every one of those floor drains? That could really interrupt the space and the mechanical systems. So this gives us the ability to catch those floor drains and still maintain venting. Now, of course, it has to have a vent that goes out the roof. We've talked about that. Now, when a combination waste and vent pipe is correctly sized, it removes the limitation for the distance from a vent. Now, we've mentioned there has to be a vent somewhere associated with the building drain, but we can actually extend quite a ways out if necessary in order to catch that fixture, again, if it's sized properly. In this diagram, we see a series of fixtures that are being vented using the combination waste and vent system. Sinks and floor drains that are branching off of the building drain. You can see for the sink, it may rise up into the wall a ways, come over to the trap, but we do have an 8-foot maximum on those rises as they go to catch those fixtures. As with our other venting systems, the combination waste and vent system does have a sizing table. So once again, we've got diameter pipe on the left. The second column gives us the maximum number of drainage fixture units that can connect to a horizontal branch or a stack. If it's connecting directly to a building drain, we have a larger drainage fixture unit value associated with that pipe. So you can see that on the third column. Section 916 gives us island fixture venting. This is kind of a dinosaur. I mean, it still works, it can still be installed, but this is how we used to handle island fixtures, say in a kitchen. You'd have to create all of this piping coming up to the drain, create a vent loop, tying back into the drain below, coming across underneath, tying into some other venting. There's quite a bit involved with island fixture venting. Once again, I'll say it is approved, and in 916 it details how we are to do that. I'm not going to go into a lot of detail here though, because most of the time now we are using auto vents rather than this. It takes much less labor, much less material, and it is also approved. Let's have a look at 917, the single stack vent system. This is a relatively recent addition to the code, meaning within the last couple of code cycles they've added this back in. The single stack vent system is kind of going back to the original design of plumbing, when in large buildings in big cities they would just run one pipe all the way up and dump everything into it. 917.1 kind of defines that, and it says wherever this is permitted, we're saying that the drainage is also the vent. It's just one big pipe, and for that reason we have a sizing table specific for single stack vents. On the left column we have our pipe sizes, and then you'll notice on the next 3 columns where we're looking at the maximum connected drainage fixture units is divided into the height of those stacks, the shortest being less than 75 feet high. Then we get from 75 to 160 feet high and 160 feet and higher. So these are definitely designed for our high-rise buildings. As we look at more of the specifics on requirements, it has to be sized according to the table, uniformly sized for the drainage fixture units. Again, the vent equals the stack, so it's the same size, it's the same pipe, and there's a requirement that 3-inch stack cannot serve more than 2 toilets. 917.3 states that the toilet connection has to be within 18 inches of the stack. And so long as that toilet is within 18 inches of the stack, it can have one branch coming off of that would be a 1.5 inch drain maximum. Now this requirement would be specific to the 3-inch pipe going to the toilet. If you get into a larger size pipe, then you can branch a little farther with these horizontal branches. You can see in this diagram you can go up to 12 feet maximum with those branches. The smallest vertical portion branching up off of a horizontal branch like that is 2 inch. If the pipe is to serve a urinal, it has to have a 3-inch vertical coming off, and the maximum height for any of those verticals is 4 feet. If we have to raise any higher than 4 feet, it would require a separate vent. Now, if this stack has to be offset, it's going to play by the same venting rules as we looked at before for offsetting a stack. But in this case, if there are no branches below the offset, then it wouldn't need to have all that venting. In 917.8, it talks about prohibited lower connections. You have to imagine when you have a huge high rise and all of this waste is coming down in this stack, what's going to happen at the bottom? You're going to have huge amounts of compression and pressure. And at those 2 lowest branch intervals, it can have that waste just blasting out of the fixtures. So the last 2 branch intervals, maybe the last 2 stories of that building, are going to be on a separate stack. That way all the rest of that pressure is just going to blast in the bottom of the other stack without affecting fixtures in those lowest floors. For sizing of building drains and sewers connected to that type of venting, we just go back to chapter 7. As you can see, there are a variety of methods that you can use in order to vent drainage pipe. If you're following along in the book, you may have noticed that I didn't dive deep on some of this, and I strongly encourage you to go back and read through the requirements. Make sure that you understand what is being explained. I'm just hitting the main points and trying to help you understand what these look like. We still have a little bit more to cover in chapter 9. In the next presentation, we'll look at air admittance valves or auto vents, and we'll finish off the chapter. I'll see you then.